And welcome to this video on the topic of projectile motion. So here is your building of 74 meters and you're projecting the body at an angle of 30 degrees. 27 meter per second is the velocity of projection. So this is your u. And as soon as you see this problem, the first thing that strikes your mind is that this is a problem of free fall too, because the body comes down. So essentially, when you approach projectile motion, there are two things you have to find. One is you're trying to find the time of flight, which means the time it takes to strike the ground. And second is kind of range, which is how far does it fall off from the base of the building. So you're trying to find kind of range and how far does it. Now the way you approach this is pretty straightforward. You split the motion in x and y axis. If you see the initial velocity in x is ux, and if you take the components, component number 1 is this and the component number 2 is this. So this is your 27 cos 30 degrees, and your uy is and just be very cognizant of the fact that you're moving on the right hand side when it comes to, so this is plus, and when it comes to initial velocity, it is downward. So you put a minus sign here, and this is minus 27, and cos, and this is opposite of, so this will be sine of 30 degrees, okay? This is sine of 30 degrees, this particular component, okay? This is uy. And you just start off with your motion, and this is cos 30 degrees, okay? And this is your 27, okay? So this is the way you start your motion. There is an acceleration in negative, downwards, which is minus g. There is no acceleration here. The displacement is downwards, so you put a negative sign again, which is minus 74 meters. And you have to obviously find, this, and you have to find the time. I'm writing time on the right-hand side because, in a free fall situation or a projectile situation, every projectile motion is a free fall, So the time of flight is dictated by the y-axis, okay? This is what decides time of flight. So if you know the initial velocity, s, a, and you have to find this, just apply the second equation of motion, which is s is equal to ut plus half ad squared. And you have to be very careful when you solve this, that you are going to apply the, the sign convention, which is very, very important in, this kind of numerical. So what you do is you apply this sign convention and, okay, so let's apply the sign convention and put this as minus 74 is equal to minus 27 into t minus half into 9.8 into t squared. So the displacement is downwards. The initial vertical velocity is downward. The acceleration due to gravity is downwards. What you get in the end is minus 74 is equal to minus 27t minus 4.9 t squared. So this is your quadratic equation. 74 is equal to 27t plus 4.9 t squared. And if you solve this up, what you get is time. So you get the time of flight using this quadratic equation. So once you find that, the only step left is you to find the horizontal distance, right, which is your range. So you put it as r is equal to the initial velocity in the x-axis, which is 27 cos 30 degrees, root 3 by 2 multiplied by the time which you found using this quadratic equation. Now, trick in this question is to emphasize the fact that the time of flight is always dictated by the y part of the motion. So split the motion. This is your uniformly accelerated motion under the influence of 9.8 meter per second squared. And on the left-hand side, what you see is just the horizontal part of it. So pretty straightforward numerical. And if you want to do it in a methodical manner, and you must know how to solve the quadratic equation and ensure that once you get the two values, you know how to select the value intelligently, right? So you may get one negative time and the other is positive time. Select the one which is positive. I hope this helps and you like this. Thank you very much for your attention.